Hi everyone. I'm going to be doing from segel on 319, number 6. This one is actually very easy, but the hard thing about it is what assumptions you have to do. Okay, so if we look at it, let me get that out of your way. Sorry about that. It's going to equal an enzyme with a Km of 1.2 times 10 to the negative fourth was assay initial substrate concentration of 0.02 by 30 seconds 2.7 micromoles per liter. Product had been produced. How much product will be present at 1 minute, 95 seconds, 3 minutes, and 5.3 minutes? What percentage of the original substrate will be utilized by the times indicated? Okay, so one thing that I made a mistake on, if you came to my office hours, was I made the wrong assumption. I was assuming that S was much greater than Km, and so the two assumptions that you can make here is, if you notice that the right assumption is when Km is going to equal 1.2 times 10 to the negative fourth, and S is going to equal 0.02, S is much greater than Km. Okay, what this means is that when you write your V over V max equation, which is S over Km plus S, S is so great that Km isn't going to play a factor. And so you're left with S over S, which means that this is pretty much going to equal almost 1. What that means for us is that V, our current velocity, is going to be almost at our Vmax. It's going to be very close. Okay, when you look at the Maclaurin-Smith equation, when you look at this graph, right, your velocity is linear at this point, at Vmax. When it's approaching Vmax, it's almost linear, which means your velocity doesn't change for any time. Okay, so what they give us is they give us this. At 30 seconds, 2.7 micromoles per liter has been formed of our product, right? So what that means is that in order to find out where our velocity is equal to micromoles per liter per second, or per time. I'm going to convert this into minutes just because I'm more comfortable. You can have it in seconds, but for me, I like minutes. So all you're going to have to do is just convert. So all you're going to do is you're going to take this and to divide it by this to get your appropriate units. So your V is going to equal 2.7 micromoles per liter times 1 over 0.5 minutes. And this is going to give you your velocity. What you should get is you should get 5.4 micromoles per liter per minute. Okay. The actual part A of this too asks you what is your concentration at 1 minute. So we can times this by 1 minute, and we're going to get 5.4 micromoles per liter. Okay, pretty easy. All you're going to do is you're going to convert, for using this formula I have, you're going to convert every single one of your times into minutes. So when they give us 95 seconds, we're going to times it by 1 minute over 60 seconds. Seconds are going to cancel out, and we're going to be left with 1.58 minutes. Okay. Then we're going to take our velocity and times that by our time. So our velocity is 5.4 micromoles per liter per minute, times that by 1.58 minutes. It's going to equal 8.55 micromoles per liter. Okay. I do just briefly want to kind of go over something that Gassier in my when he taught my class, he went over, and it's just kind of how to apply this to this type of equation. I'm not sure if it's going to be asked in the final. I have no idea, but I think it's still pretty cool. So I'm going to go over it. If you don't want to see it, you don't have to. So what would happen if now our Km is going to equal 1.2 times 10 to the negative fourth, and our S was equal to 0.02 times 10 to the negative seventh. Let's just say it's really, really small, right? So yeah, I'm kind of skipping over the answers for the rest of them. Hopefully you can figure it out for yourself. All you'd really do, sorry, just kind of going back, for part E that asks for your percentages, you take however much you made here, which is 2.7 or 5.4 or whatever. It'd be this divided by 0.02 moles. Make sure you times this by 10 to the negative 6th. That way you have your units the same.